Now, our next session is called Decision Making for Grown-ups, and I'm very excited to be able to hear this as a grown-up and as someone who makes decisions, but even more so because our speaker has more than 20 years of technical experience. Liz Keogh has been instrumental in providing value as a developer across BDD, but also now within the lean and agile spaces. And I'm particularly looking forward to hearing about Cynefin, which is a framework that she is a leading expert in. So thank you very much, Liz, for joining us at BITR conference. Over to you.
Hi everyone. Welcome to Build IT Right. I'm Liz. It's a real pleasure to get to talk to you today. This is a recorded talk, but I'm live on chat right now. So if you have any questions through the presentation, please don't hesitate. Just ask them. We can have a conversation while this talk is going on, and that will be really good for me. I've really enjoyed that. So the thing I want to talk about today is decision making and how we tend to do it wrong as human beings. Somebody once asked me what my favorite thing about human beings was, and I said it's our ability to see patterns even in uncertainty, even when we're not sure about them, and to move forward based on those patterns allows us to advance, even though all the data around us is so overwhelming we couldn't possibly make sense of it all. What we do is we see patterns in that data and it allows us to actually progress. And they asked me what my least favorite thing about human beings was. And I said, it's our tendency to see patterns in data that doesn't exist and then progress in a way that's really wrong. So these cognitive biases, heuristics that we use in our day-to-day decision making, they simultaneously help us because if we didn't have them, we wouldn't be able to operate, and they trip us up. So that tendency to see patterns, there's a word that you're probably familiar with called epiphany. It's that sense of when you see the pattern and you think, oh, I get it. There's another similar word. It was coined by a guy called Konrad Klaus. He's a German psychologist, and he coined this word epiphany to mean that sense of epiphany that schizophrenics get. When they see the pattern, they go, oh, I get it, but they're wrong. They're seeing a pattern that doesn't exist. That word epiphany has come into English as apophenia, our tendency as human beings to see those patterns. So I want to share that experience with you now. I'm just going to share some slides with you. I'm going to share this picture and then I'll come back. All right. Let me share this. Okay. Are you ready? Are you ready for this experience? Can you see it? If you can, maybe shout out in the audience, what do you see? Can you see what it is? It's an elephant. I can see the elephant really, really clearly. It's actually a lava flow on Mars. This is the Elysium Planeta that was taken in 2012 by the Mars Reconnaissance Orbiter. But it looks like an elephant, and most people looking at it can see the elephant. If you couldn't see the elephant in that one, maybe you can see this one. Can you see the elephant in that one? This is Elephant Rock in Iceland. So it's not even just human things. We see animals, we see anything that's familiar to us. We start seeing in images. If you can't see that one, how about this one? That's not a tree. It's an actual elephant. So this is an actual elephant. I'm wondering how many of you know what kind of elephant this is. Big ears, big elephant. It's an African elephant. Most people will probably recognize it. And of course, if that's an African elephant, then this one with the smaller ears and the big domed head has to be an Indian elephant, an Asian elephant. It is an Indian elephant, which is a subspecies of the Asian elephant. How about this one? What kind of elephant is that? Some of you will be thinking African because of those big ears. But I bet very, very few of you will recognize that that is a different species to the first elephant. Did you know there were 3 elephant species? They've got different shaped skulls. The African flesh elephant, African forest elephant, different shaped skulls, different number of toenails. The African forest elephant is smaller and darker. Their lines diverged around the same time as the mammoths, right? Diverged from the elephant line. So these are 2 completely separate species. They really don't interbreed. And this was only discovered in 2002. Now, unfortunately, what happens is the conservationists who put the processes in place to look after these elephants, because they didn't think that there were 2 kinds of elephants, they still only count them as 1 kind of elephant. They made a decision really early on that there was only 1 kind of elephant and they were only going to worry about conserving African elephants. And it's proved really, really hard for some of those conservation groups to actually change to encompass both kinds of elephants. Now, this is a discovery that has been waiting for millions and millions of years. And we still made the wrong choices. We still made the wrong decisions. And we fixed our processes in place as a result. Okay, so what I'm going to teach you today is how to make better decisions, particularly when there's uncertainty, because there wasn't really a lot of uncertainty here, right? That you can count elephants' toenails. But when you've got uncertainty, the chances of making these discoveries are even higher. And we are really, really bad at dealing with uncertainty. So I want to talk first, just to give you an idea, about something where we start with uncertainty. This is all going to be familiar to all of you. We start with uncertainty, and then we gradually move to a place where we're more certain. This is called the innovation cycle. So I got this from David J. Anderson. But on the background, you can see a diagram. I'm going to introduce that diagram to you in a moment. I just want to share this first, just because it will be more familiar to you. Okay. Do you remember the very, very early camera phones? The very, very first people who developed them were people like Keogh and Sharp. So what they did was they put them in landscape mode and they had the camera facing towards the user because they thought that people would want to make video calls with them. And it was a differentiator for them. So it was something new that nobody had really done before. And it turned out that the internet was a bit slow and that these cameras, nobody wanted to make video calls with them. They wanted to take photos. So Nokia, very famously, they put the camera on the back of the phone. They saw what the fun that Keogh and Sharp were having. They said, we're going to spoil your fun. We're going to spoil your differentiator. We put the camera on the back of the phone and we let people take video calls. So they had a little mirror. That was how you took a selfie back in the day. There was only 1 camera, so you had a little mirror for taking selfies. Now, of course, it's become commoditized. Cameras are so ubiquitous, so cheap, so well understood that I've got 2, one on the front and one on the back. My partner's got an Apple phone, you know, one of the new iPhones. I think they've got like 4 or something on them. So it's really, really ubiquitous. And as a result, people have been able to build on this certainty, on the fact that it's well understood problem, everybody's got one. And so you get things like Pokemon Go and virtual reality apps. Okay, so this is familiar to everybody. When I'm doing this as a training course, I sometimes ask people, can you think of any other technologies? Look around your room. What can you see that's also gone through this cycle? It's almost everything goes through this cycle. Okay, let me introduce you to the framework that's behind that. This is the Cynefin framework. It's a Welsh word. The hardest thing about pronouncing it is pronunciation. It's Cynefin, like Kevin with an N in it. It's a framework for making sense of different situations and how to approach them, depending on how certain or uncertain things are. So Dave Snowden, who created this, when he introduced it in his, it was an article he wrote for Harvard Business Review called A Leader's Framework for Decision Making. He said, we're not just best fit pattern matchers. We don't just pattern match and settle on the best fit. We are first fit pattern matchers. So this framework offers a lens to see the world that helps to counter that tendency. And I will tell you, it only helps. We're human. We still jump to those outcomes. We still pattern match to the wrong things. So let me show you how we can help with it. So there are 5 domains in Cynefin. As you've seen, things move around. It's not static. This isn't a matrix. There's 4 main domains and 1 in the middle of the line of truth. So the first domain that we tend to come across is the obvious domain. So an obvious problem is either one which children can solve, or if it does require expertise, the solution is obvious. So I go to my landlady in the pub. I go, what do you do when the beer runs out? She says, well, I change the barrel. Obviously, duh. It's a duh problem. It's a one of those. Okay. And we can categorize the problem. One of those problems. Seen it before. As things become more complicated, they require more expertise. So a watchmaker knows how to fix your watch. A car mechanic knows how to fix your car. A lot of mechanical, well understood problems end up in this space, right? Predictable outcomes, but you do need expertise to solve it. Because it's got a predictable outcome, you can close the gap between what you have and what you're hoping to get, and that's called analysis. Right? So you can analyze the problem because you know what you're aiming for. You know what a working watch looks like, a working car. We have a problem dealing with chaos particularly. Chaos is the highest uncertainty you can get. It's accident and emergency. It's your house burning down. In 2012, there was a company called Knight Capital Group. They released something to 7 of their 8 servers, and they forgot the 8th one. And when they went to market on Monday morning, that 8th server put something into the marketplace that basically started putting spurious trades into the marketplace. And all the other people trading saw and responded. All the other automated systems saw and responded. By the time they had found the problem and turned it off 45 minutes later, they had lost $440 million. And it prompted their fire sale. You can go read that story on Wikipedia, right? $440 million. That's why we don't like chaos. Chaos resolves itself very quickly. It's a transient domain and not necessarily in your favor. It is dominated by urgency. It is also the domain of urgent opportunity, but it's normally regarded as a really bad place to be. So in chaos, we have to act and act quickly. This gives us a problem when we're dealing with things which are not so urgent. There is time to try things out. It could be made safe. But because it's uncertain, we don't like it. We associate uncertainty with chaos. There was actually an experiment that University College London did with snakes under rocks. It was an electronic game. They had basically got people to turn over these rocks, and if the rock had a snake underneath it, they got an electric shock. And the object of the game was to turn over all the rocks without snakes underneath it, so you had to learn to predict the snake population if you didn't want to get shocked. While they were doing this, they measured people's stress levels, and the people with the highest stress were the ones where they gave them a 50% chance of snakes under rocks, not the ones with 80% chance of snakes under rocks who are getting all the shots all the time. They kind of just got resigned to it, I guess. Not the ones who weren't getting shot very often, but the ones who didn't know whether they were going to get shocked or not. They were the most stressed. And there have been so very many experiments that show we do not like uncertainty and we're really, really bad at dealing with it. And so this gives us a problem dealing with complexity. Complexity is a high discovery space. It's where innovation happens. But because we don't know what the result will look like, it emerges. Cause and effect here are correlated in retrospect. We have to try something out that's safe to fail. In complexity thinking, we call that probe. So it means trying something, and if it doesn't work, that has to be okay. Right, so you can either put safety nets in place or do things at a small scale. And I'll talk a little bit about how this correlates to what we do in software development. Okay. There are some best practices that go along with this. In the obvious domain, there's only really one way to do things, and I'll talk a little bit about why that is in a moment. In the complicated domain, we have multiple ways of doing things. It's good practice. It's still well understood. So experts know how to do it in different contexts. In the complex domain, we have these emergent outcomes. So we have emergent practices as well. So cause and effect are correlated in retrospect. That means what we do is to make it work is correlated in retrospect as well. We can see what works with hindsight, but we can't predict it. In chaos, because we have nothing to lose, this is a domain of novel practice. I won't talk about that, but there are some things online if you want to go look at that. Look at the shallow dive into chaos if you want to know how to use that in a way that allows you to get those novel practices emerging. Okay, and I'll talk in a moment about these constraints as well. All right, so estimating complexity. This is a little scale that I use when I'm doing software development to help me work out which of those domains I'm in. So I ask, who in the world's ever done it before? 5, nobody in the world's ever done it before. It's completely new. It might not work at all. This is like going to Mars. Nobody's ever done it. So you better be doing it in a safe space. They're actually trying it out in Antarctica at the moment. 4, somebody outside the organization's done it before, but we've got no access to their expertise, so we have to treat it like it's complex. 3, somebody in the organization's done it before, or we have access to expertise a different way, so we can learn it from a book, learn it from YouTube, learn it from a training course. 2, someone in the team's done it before. 1, we all know how to do it, right? This is just a really rough guide. I showed this to somebody who was doing a target operating model, and he had invited people to come and see his target operating model, and as part of that, he asked me to talk about Cynefin. He saw this, he said, so the 5s and 4s, that's where all the risk is. I said, well, yes, those are going to be the high discovery things, right? None of this is chaos, by the way. If you're in chaos, you shouldn't be doing this act. But these are the complex high discovery things. There's unknown unknowns in there. You know you're going to discover something, but you don't know what it is. He said, but that's also where the value is. That's why we're doing what we're doing. I said, yes, absolutely, because we're always trying to provide new capabilities to people. New capabilities. The system is going to enable people to do something that they couldn't do before. And when we find out what that thing is, you know that that's going to be the high discovery space. So get it done early. And he looked at these, he said, we should start with those while we've still got time to react. I said, yeah, absolutely. It's what I tell people. He said, but the entire industry does it the other way round. I said, oh, yeah, they do. And what he had done, he had the whole of his target operating model on the background, on the back wall with these big holes in it saying TBD, to be decided. He had put out all the 1s, 2s and 3s that were analyzable, that he understood, and hoped that the rest would drop out later. And of course, when you find out what the 5s and 4s really look like, you have to redo a lot of the work of those 3s, 2s and 1s. He realized that what he should have done was attack the 5s and 4s early and get feedback on those, because those were the things that were likely to cause discoveries. So when you're looking at your software development, I actually use these. The way I do this is I think about capabilities. I think, what do we need to be able to do with this system? And what's new about this? What's the 5s? What's the 4s? If you can narrow down into one of those and get as little as possible to make that thing work, that's an MVP. If you can narrow down into one of those and do it early on, it probably looks like a spike. It probably looks like a prototype, because you want to make lightweight investments in it to check that it works early. I know a lot of teams where they start their journey with logging in because it's the first thing. Don't log in. You've got one user, they're already logged in. What are they logged in for? What's the outcome that you're approaching? Can you get something working that demonstrates it, that you can show to people? Because I guarantee if you show it to people, either they might be really happy, or they might go, yeah, that's not going to work, is it? And that's where the discoveries come in. This is why agile software development is so important, because people don't always know what they want, especially if they've never had it before. And we're not great at handling that. But now you have a lens that you can use to see it. In the middle of the Cynefin diagram is disorder. Disorder is the domain where we don't know which of these dominate, and so we behave according to our preferred domain. For most people, that means big upfront plans, dividing everything into all the stories really early on, and then sticking to it, arguing with the business when they want changes. Change is a natural part of this. It's always going to happen. So see if you can embrace that uncertainty, get fast feedback, make the investment you're putting in this really lightweight. That's how you make it work. This is how they look on the Cynefin diagram. And like I said, this is just a guide. It's really approximate. The 5s and 4s complex. 4s are still, they're spoilers, so you know somebody else has done it, but you don't know who got fired for taking too long. You don't know how much it cost. You don't know what technology they were able to repurpose. So it's still going to be high discovery for you. 3s, perfect complicated territory, perfect for analysis. Schedule access to your experts if they're not part of your team. I really like doing BDD in this space. It works really well to ask for examples and get their knowledge from them. 2s and 1s, that's logging. That's login, and it's boring. Don't worry about it. Because the outcome is so well known, you can actually just outsource that stuff, and people will get it right because they know how to do it already. Find somebody who knows how to do it, get them to do it, or give it to a junior dev, because again, the outcome's really well known. Okay, so I said I was going to talk a little bit about the constraints. So I'm going to share the constraints in this slide, and then I'll switch back so you can see me. Okay. All right. So obvious has fixed constraints. That means there's only one way to do things. Complicated has, chaos. Okay, I did chaos first, has no effective constraint. And I'll talk a little bit about that too. In the complicated domain, we have governing constraints. And in the complex domain, we have enabling constraints. And the governing and enabling are the really interesting ones, but I'm going to talk about all of them. All right. So you can see me again. Okay. So fixed constraints, obvious stuff has fixed constraints like a plug, right? I can't put this into the plug socket the wrong way because everything about it means there's only one way to do it. There's only one way to get it right. Okay, so plugs are fixed constraints. Okay, complicated, mechanical, well understood, right? It's very predictable. Maybe the software that's inside it might not be, because software these days is beyond our expertise. There's so much of it, it's really hard for one person to understand, which is what makes it complex, is our inability to deal with the data. But machines are complicated. This is also evolving, so you can argue it's more to the complex side. Like I said, things move around. Okay. The governing constraints, the thing about governing constraints is they are context free. Okay, that means they apply regardless of context. So when Dave Snowden talks about this, he talks about like a cup, right? This cup holds the coffee. The coffee can't get out. There's no way for the coffee to get out unless I turn it upside down, because physics is also governing constraints. But it's holding the thing in. He talks about a seawall. So when you have a seawall, When it breaks catastrophically. So you'll find governing constraints are these hard and fast rules that apply regardless of context. So you can think about traffic lights, red lights. The only people who get to skip red lights without consequence are really, really highly trained, and they drill that, they practice to avoid that chaos. But for you and I, we can't really skip the red light without risking chaos. Okay, because if it goes wrong, it's going to be catastrophic. So governing constraints, when they break catastrophically. And they apply regardless of context. Hard and fast rules apply regardless of context. When you think of a sink has an overflow hole in it. So as the water level rises, it goes through that hole first. So you get a little bit of grace period, you get a little bit of warning. So it's less governing. There's an exception. Dave Snowden also talks about a marsh next to the sea, which is like a sponge, right? So as the water comes in off the sea, as it's flooding, a marsh actually absorbs a lot of the water, and you can see the sea level rise. So rather than breaking and flooding a village catastrophically, the people in the village can see it coming, and they've got time to build sandbag barriers, and to do something about the fact they're about to be flooded. So it gives a piece of warning. That's the difference between the governing and the enabling constraints. Enabling constraints have escape clauses. They're permeable. Things can get through them. So one of the things that I look at when I'm looking at processes in a team is I go, okay, are you in chaos? Because chaos is chaos because it has no constraints. This flame is actually constrained quite tightly right now. If it were to catch fire in my room, the whole place would go up, and it would keep burning until it ran out of things to burn, until it met constraints, right? Or somebody put some constraints on it by putting the fire out with flame retardant. So chaos is caused by a lack of constraints. So one of the things I look for is, are you in chaos? Are there fighting fires? Are you thrashing? Are you not knowing what's going on? And maybe I put some lightweight constraints in place, some guidelines and heuristics. It doesn't mean you have to do them, but you can use them as principles, sensible things that you can look at. Okay, maybe that helps. And we try them out. We see if they work. Everything's different. If I'm seeing that people can't get work done, that their creativity is being stifled, maybe you've got some CAB process that's really hard. It applies to absolutely everything, even a tiny bug fix. I recently came across one situation where the people who wanted to deploy something had made a change to a deployment script. And they had to redo the whole CAB process just to get the deployment script working, even though they hadn't changed that actual functionality they were deploying. It was that hard and fast a rule. And because of that, that's a governing constraint. If you want to have creativity, if you want to have innovation, you have to make holes in this. So maybe you could ask something like, well, could we get something deployed without going through the full CAB process if it was just a bug fix? Or if we had full automated tests and could show we got 80% coverage with no breaks, if we've been 6 months with no significant production issues, can we make a hole in the CAB process? Can we do something that means this is a guideline? Do we absolutely have to talk to a BA every single time we start work, even if it's really obvious? It's that kind of thing. Can we make a hole in that process? Would that enable us to move more freely? So by looking at whether you need to add constraints or remove, loosen up constraints, you can start looking at how to change that process. And that for me is really magical. I will try all kinds of different things and see which ones land with a particular team, because it's always different, every team. And I'm going to talk a little bit about that as well. Before I do, I want to share something with you that I think plays into this really nicely. And that is Wardley Mapping. So this is Simon Wardley's map, right? This is an example of his map. What he's done, he's mapped how visible things are on the screen with to a customer, sorry, with how mature the technology actually is. So here he's got an online photo store that manipulates your photo images. It was one of his first maps. And you can see as the technology gets more and more mature, so it moves off to the right. Okay, moves off to the right. So you get things like computing power. And it was something where you would buy a server. Now, of course, it's moved all the way to the right and you've got AWS and things like that. So you can just get computing on tap. It's become a commodity. Everything always moves to the right. But there's inertia that stops it moving to the right as well. So you find that that thing that was custom built, now there's a product which does it even better. And you have to tell somebody that that thing that you produce that's custom built, you should have actually been using this, or you should now actually be using this library, and you have to let the thing go. So it's a matter of deciding based on how much certainty or uncertainty is, how new the thing is. Should you be custom building it? Should you be getting a product? Should you be it now a commodity? Should it be cheaper than it is? Is there somebody who's doing it at scale really cheaply? Okay. This helps you work out whether you should be building or buying, just because you can look at it and go, okay, so we shouldn't be custom building stuff that's not a differentiator for us. But if it is a differentiator, we definitely don't want to outsource it to somebody else. We don't want to be renting something from somebody else. We don't want to be buying a product off the shelf because nobody has done this before. And we're doing something that's new. He also talks about different kinds of approaches to these things. He talks about pioneers, settlers, and town planners. And it always feels to me like, you know, the pioneers are those hacky startup culture people who can get something out the door and it works, but heaven help you if you have to maintain it because it's a spike. Startup cultures, I think, do this thing called chaos grazing, where they have novel ideas and then they just stabilize them just enough to move on to the next novel idea because they're always operating with this urgency and about to run out of money. Whereas when you've got a stable product, if you're turning something that's custom built into a stable product, people want those to just work. They want them to be bug-free. They want them to be easy to maintain. So at that point, you really want to be looking at the quality of your work. You want to be stabilizing it. You want to be refactoring it, putting it under test, making sure that what you've got is really high quality code. I think I'm a settler. I like refactoring things for fun. So I'm less good at hacking things out and getting them out the door. I like doing TDD. I like refactoring things and getting them stable. The town planners are your architects. They're the people who are going to work out where in the landscape the big systems are going to go, whether they're going to go with AWS or Google Cloud or Azure, you know. It's those kind of big decisions that they're going to make. So with that in mind, now you can see how could you map your stack? What kind of insights would it give you? I will tell you that a lot of the value of this is the conversations that you have while you're having these discussions about where things are and where things are moving to. Simon Wardley's been very kind and given this away for free. So it's online, you can go see it. All right. Let me stop sharing. Okay. So I've given you a couple of ideas about how you can make things work, how to move constraints, how to use this idea of uncertainty and decision making to make better decisions, right? So you can use the lens of Cynefin, use Wardley maps. There's one kind of system that's always complex, and it's a human system. We're what we call complex adaptive systems, a system in which the agents of that system can change the system from the inside. And as a result, when we try to make changes with our systems, we can only see which ones are working in retrospect. So I wanted to talk a little bit about why I try multiple things out. why, as a coach, I have to allow those outcomes to emerge. So I'm going to share something else from Cognitive Edge as the last thing I share. This is something they call triads, and it leads to a thing they call fitness landscapes. So Cognitive Edge have this little survey tool called SenseMaker. And they have these prompts that say, you know, imagine your best friend was applying for a job at your company. What story would you tell? And maybe you tell a story about how somebody showed initiative and got really punished for it, and it was bad, and it's a bad culture because you don't like your company very much. So they put this little triangle here, and then they ask you to move a counter. Where do you want to move this counter to? So you probably, you're showing initiative and you thought you were applying a bit of good practice, but you definitely didn't understand the context, right? So you'd move it up to the top. What they do then is that they measure how far everybody's counters are from the different corners, and they have multiple of these triads. And from that, they start making graphs with different kinds of things on the graph. And they've got 4 dimensions to play with. Sorry, 3 dimensions to play with. They've got, you know, height and bottom, and then they use height as well. So they put these things like, I've forgotten what you call them. The contour lines on a map, right? They're contour lines. And they produce this fitness landscape with them. So at the bottom, you can see there's this tight little cluster of people. Now, if we decided that up was a better direction for them, we're trying to push them up, you can see nobody is telling stories which are in that direction, right? Nobody's telling any stories which are similar to a place that's up. So you can tell from that those kind of stories probably aren't supported in the organization. This would be like me coming in and teaching BDD, but there's a massive division between the devs and the testers, and I'm never going to get them talking to each other, right? So BDD just isn't going to work. It doesn't matter how much I try and push it, how much I try and push talking through examples and automating tests, it's not going to work. Oh, maybe automating the tests would work though. If I find that over here there's some people talking about automated tests, that would tell me that that is supported in the organization. So the conversations might not be, but maybe that's a way to get it to a better place and remove some of those constraints that are stopping the devs and testers talking. Maybe the testers are just really, really super busy testing the devs' buggy code. So what we're doing, we're finding what's called disposition, things which are likely to work. And you can do these even if you don't have SenseMaker, either by running paper SenseMaker, so you can do these surveys on paper, or you can just listen to people's stories. And when we find something that's working, when I find something that a team is doing that's slightly better than other people, and it's really, you know, it's good stuff, what I do is I ask them to share it and to spread it. And this is what we call amplifying a working probe. So if a probe fails, you want to be able to dampen it. But if a probe is working, you want to amplify it, you want to spread it, you want to anchor it in place, make sure it carries on working. That reinforcement of things that people are doing that are really good, I get more change as a coach from that than anything else. So if you want your organization to be better, something you can do, as well as looking for what constraints you can change, is look for other people who've managed to change those constraints. Look for other people who are doing something different, doing something new that's working, and see if you can adopt those, see if you can support them, see if you can get them doing a talk, doing a lunchtime talk, put a poster up on the wall, anything which allows that new culture to start to spread. That's how we do cultural change, not by demanding that somehow we end up at this agile state, end state, that's fixed and predetermined, but by trying lots and lots of things out and allowing that outcome, those good outcomes, to emerge, because we're complex and because uncertainty is an inevitable part of our lives. That's all I wanted to teach you today. I hope that was really interesting. I look forward to seeing what questions you come up with on the chat. I probably answered some of them by now. Thank you very much for being with me, and I hope you had a fantastic conference.